We had a test in AB Calculus earlier this week. In fact, it was a semester final. And because I wanted to show justification on this, I think I changed the time allotted here to 50 minutes instead of 40 minutes. So there are 19 problems total. We'll go over these pretty fast. The limit as n approaches infinity as for 3n cubed minus 5n plus 1 over 1 minus 2n squared minus n cubed equals, well, that's going to be the horizontal asymptote, the limit as the function, the independent value approaches infinity. So in this case, we have the highest powered exponent in the numerator is 3 and likewise in the denominator. So what we do is we take the fraction of the coefficients, which is going to be 3 in the numerator and -1 denominator, and that's going to simplify to -3. So the value of our horizontal asymptote is -3. Next problem. The function f is given by fx equals x cubed minus 12x plus 24 is. A lot of these problems are increasing, decreasing problems, points of inflection, maximum, minimums. So let's go ahead and find the first derivative of this function. F prime of x equals, we have 3x squared and minus 12. And if we set our first derivative equal to 0, we can factor out from the greatest common factor is 3. So you have 3 times quantity x squared and minus 4. And x squared minus 4 is going to simplify to, we can divide by 3 first of all, get rid of that 3. And so we have 0 is equal to this x squared, 20x minus 4, which we can use difference of squares as 20x plus 2 times 20x minus 2. So our critical numbers are x equals -2 and x equals 2, solving each one of these factors for 0. And so we can now construct a number line, evaluate between -2 and 2, and on the top I'm going to put f prime of x, and the bottom f of x. We evaluate a number of less than -2, which would be, say, -3. That's going to be a negative times a negative, which is positive. So our function is increasing from -infinity to -2. And then between -2 and 2, say 0, we have -2 times 2 is negative. So our function is decreasing between -2 and 2. And then to the right of 2, say 3, we have positive times positive. So our function is increasing. So our function is increasing for x is less than -2, decreasing between -2 and 2, and increasing. So it looks like A is going to be our correct answer. And so that's our justification. And so an equation of the line tangent of the graph of y equals the quotient 2x plus 3 over 3x minus 2 at the point 1, 5 is, well, first of all, to find the line tangent, we need two things. We need a point and a slope. We'll just verify that our point is 1, 5. If we plug in 1 to this function here, we have 2 times 1, which is 2 plus 3, that's 5 in the numerator, and 3 times 1 is 3 minus 1 in the minus 2 in the denominator, that's 1. 5 over 1 is 1. So that checks out. So our point is going to be exactly that coordinate pair, 1, 5. So next we're going to take the derivative to find the slope, and for that we'll use a quotient rule, and I'm going to find the high is 2x plus 3. The derivative of our high is 2. Our low is 3x minus 2, and the derivative of our low is 3. And so y prime is going to be equal to our low, and our low is going to be quantity 3x minus 2 times the derivative of the high, which is 2, minus high, and high is 22x plus 3 times the derivative of the low, which is 3, all over low squared, which is 3x minus 2 23x minus 2, 23x minus 2 squared. And then just simplifying out, we have y prime is equal to, in the numerator we're going to have 3x times 2, which is 6x. And we have negative 2 times 2, which is minus 4. We have negative 2x times 3, which is going to be minus 6x. And then we have 2 times 2, which is 9, and minus that, so minus 9, over, we still have quantity 3x minus 2 squared in the denominator. And simplifying out, we 6x and 6x cancel each other, so we're going to have in the numerator negative 13, and in the denominator we're still going to have this quantity 3x minus 2 squared. And then we're going to find y prime of 1, putting in 1, and so we're going to have negative 13 in the numerator, and we plug in 1 for 3, so we're going to have the denominator 3 times 1 minus 2 times, that's going to be squared, so we're going to have in the denominator 3 minus 2 is 1, squared is 1, so we're going to have negative 13. And so looking this out, just putting it in point slope form, we're going to have y minus y1, which is 5, equals our slope, which is negative 13, and we're going to have x minus x1, which is 1. So we have y minus 5 equals negative 13x, and that's going to be plus 13. And if we're going to do a double switch here. We're going to add 5 to both sides of this equation, plus 5, and subtract and add 13x, right? Plus 13x, and we get cancellation. So we're going to get y plus 13x is equal to 13 plus 5, which is 18, and that's going to be our version, it's going to be equation B. Next problem, given function fx equals x to the 5th power minus 5x to the 4th power plus 3, find out values of x for which the graph of f of x is concave up. Well, concave up has to do with finding the second derivative of the original function, and to find that second derivative, first we will find the first derivative. F prime of x is equal to 5x to the 4th power, and we're going to have minus 4 times 5 is 20, and we're going to have x to the 3rd power. So now we found that first derivative, and we can look for the second derivative. F double prime of x is equal to 4 times 5, which is 20, x cubed, minus 60, 3 times 20, 60, x squared. And to find possible points of inflection, we set that second derivative equal to 0, so we have 0 equals, and our greatest common factor looks to be 20 x squared. And what times 20x squared equals x cubed? Well, that's going to be x. And we're going to have minus, that's going to be 3, right? So that's right, because negative 3 times 20x squared, that's going to be negative 60x squared. So our critical numbers are going to be x equals 0 and x equals 3. And I said critical numbers, I mean these are possible points of inflections, PPOIs. So let's go ahead and evaluate to see what they are. Again, we put on the number line our possible points of inflection, which are 0 and 3, and we're going to put f double prime above the line and f below, and evaluate concavity. We're going to take a value less than 0, say negative 1, well, we're going to have x negative 1 squared. That's always going to be positive, no matter negative or positive, and then negative 1 minus 3, that's going to be negative. So we are concave down for greater infinity up to x equals 0. Next, number between 0 and 3, say we take 1, well again positive times a negative, so we have a negative concavity also between x equals 0 and x equals 3. And lastly, if we take a number greater than 3, let's say 4, we have positive times a positive, so we are positive for x is greater than 3, so that's going to be concave up. So final values of x for which the graph of f of x is concave up, and that's going to be x is greater than 3. Answer choice B. Next problem, f of x equals x cubed minus 3x squared for all real numbers. X has a relative minimum at x equals. We have a relative minimum we're going to find by taking the first derivative, evaluating, looking for critical numbers, and evaluating to see if we have a change from, to get a relative maximum, we have to have a change of f prime of x going from positive to negative. And so f prime of x is equal to 3x squared, and we have minus 6x. And then setting this equal to 0, we'll say 0 is equal to, our greatest common factor here is going to be 3x, and 3x times what equals 3x squared? Well, that's going to be x, and then 3x times what equals negative 6x, so that's going to be minus 2. So our critical numbers are going to be x equals 0 and x equals 2. And then we go to our number line. Okay, our number line is, again, critical number 0 and 2. And we're going to put f prime here above the line and f below. And to the left of 0, if we take a number, say, negative 1, we're going to have a negative times a negative, which is positive. So our function's increasing all the way up from negative infinity to 0. And then between 0 and 1, let's say 0 and 2, we say 1. We're going to have positive times a negative. So our function's decreasing between 0 and 2. And then next we have greater than 2, let's say 3. That's going to be positive times positive. So our function is increasing for x is greater than 2. And so our relative maximum, the only one we see is where f prime of x changes from positive to negative. And we can kind of trace like I'm doing in red. And so that's going to be our answer choice B. Next problem. 6. If f of x equals 4x cubed minus 3x minus 1, equation of the line tangent of the graph at x equals 2 is, well, again, like we looked at earlier, we need two things to find the line tangent. We need a point, and we need a slope. And for a point, well, we're going to find, we already have our x value, which is 2, right? So let's just plug in, we'll say f of 2. That's going to give us our y-coordinate. So we have 4 times 2 cubed minus 3 times 2 minus 1. And 4 times 2 cubed is 8, so that's going to be 32 minus 6 minus 1. And that's going to be 32 minus 7, it's going to be 25. So that's going to be our y-coordinate of that point. Now we find the slope. Let's go ahead and find the first derivative of function f prime of x is equal to, we have 3 times 4, which is 12, x squared minus 3. And now we just need to plug in the f prime of 2, right? So we have 12 times 2 squared minus 3, and 2 squared is 4, 4 times 12 is 48, 48 minus 3 is 45. And so 45 is going to be m t equals 45. And now, writing our equation, we're going to say y minus y sub y1, which is 25, equals our slope, which is 45. We're going to have x minus x sub 1, which is going to be 2. And already anything without a slope of 45 is gone. So A, D, E, gone. Next, simplify out. We have y minus 25 is equal to 45x and minus 90. Negative 2 times 45 is 90. So we have plus 25 on each side, plus 25. And we have y equals 45x, and negative 90 plus 25 is going to be minus 65. So our correct answer is going to be C. Next problem. 7. The absolute maximum value of fx equals x cubed minus 3x squared plus 12 on the interval from closed interval from negative 2 to 4 occurs at x equals. What we have to do for something like this is what we call a candidate test. And let's go ahead and find the derivative first to find other critical numbers. Possibly f prime of x is equal to 3x squared, and then we have minus 6x, and derivative of 12 is 0. So setting this first derivative equals 0, we say 0 equals, we factor a 3x out of each one of these terms. We're going to have x minus 2. So using the zero factor property, 3x equals 0, x equals 0 is one of our critical numbers, and setting x minus 2 equals 0, x equals 2 is another of our critical numbers. And we can go to a number line like we've done earlier here. Okay, let's go ahead. That's 2. Okay, here's our number line. We're going to use 0 and 2. And we're going to put f prime above, f below, number less than 0, which should be, say, negative 1. We'll have negative times negative is positive. So our function's increasing from greater than negative infinity to 0. And between 0 and 2 is, say, 1. Well, that's going to be 3 times 1, that's positive. 1 minus 2, that's negative. So our function's decreasing from 0 to 2. And then from 2, if we pick a number bigger than 2, say 3, we get positive times positive, which is positive. And so we're looking for relative maximum. Well, our only candidates for relative maximum, remember we're going all the way up to 4 here on the right. Our only candidates are going to be at 0 and at our endpoint 4. And so we do a candidate test, but instead of using all 4 candidates of negative 2, 0, 2, and 4, we just have to use 0 and 4. So here we are with 0 as an input and 4 as an input. And plugging in 0, f of 0 is equal to, well, we plug in 0 for this function. Well, that's going to be 12, because anything with an x is 0. So 12 is our value, so that's a possibility. And next we're going to find f of 4 and see what that gives us. Well, that's going to give us 4 cubed minus 3 times 4 squared plus 12. Well, 4 cubed is 64, and 4 squared is 16. 3 times 16 is 48, so we're going to be minus 48 plus 12. Well, 64 minus 48 is going to be 16. It's going to be 16 plus 12 is going to be 28. So our maximum, absolute maximum, is 28 and occurs at x equals 4. So our answer is A. Next, the graph of y equals fx is shown at the right. At what point does it most appear that f of x is greater than 0? So any point that does not have f of x greater than 0, we can just eliminate. So A, we have f of x is equal to 0, gone. We have b is less than 0, gone. Then it says f prime of x equals 0. Well, f prime of x equals 0 only where there is a relative maximum or a relative minimum. The only place that appears to be the case is D. But we know that is not the case at It's C or E. So anyway, that's going to be gone. So f prime of x equals 0. I think D is the only one it can be. And finally, f double prime of x is less than 0. We have concave down, right? That's concave down, so our answer is going to be D. Next problem. At x equals 3, the function given by f of x equals x cubed when x is less than 3 and 6x minus 9 when x is greater than or equal to 3 is, well, we have this manner of choices. So to test, and on your test, I was just looking for the mathematics, but I'm going to write it out here. The limit as x approaches 3 from the left side of f of x equals the limit as x approaches 3 from the right side of f of x. We need this for continuity. We see that the thing is defined. So let's just go ahead and test. And we see we have a greater than or equal to on the bottom. That means that f of 3 does exist. So anyway, we go to the left side, and so we're going to have 3 squared is equal to, we have 6 times 3 minus 9. Well, that's going to be 9 equals 18 minus 9. So 9 equals 9. So we've tested for continuity here. And let's see, any place, functions defined. Okay. And so now we just need to test for differentiability. And that's going to be limit as x approaches 3 from the left side, not this time of f of x, but of f prime of x, is going to be equal to limit as x approaches 3 from the right side of f prime of x. And for that, we take the derivative of the left side, which is going to be derivative of x squared is 2x. Now the right side, we're going to have 6. Right derivative of 6x minus 9 is 6. And then we plug in 3 for x. So 2 times 3, 6. 6 equals 6. Check. So that we have differentiability also. So our correct answer is E. Next, 10. F of x equals square root of 2x. Then f prime of 2 equals, well, we're going to do a rewrite here. F of x is equal to 2x to the 1/2 power. And so f prime of x is equal to 1/2, and we're going to have 2x to the negative 1/2 power, and then using the chain rule differentiation, we're going to multiply by 2. And so we have is 2 times 1/2, we have 2x to the negative 1/2 power. Well, 2 over 2, or 1/2 times 2 cancel each other, so f prime of x is equal to, we have 1 over square root of 2x. And we're going to now evaluate it 2. F prime of 2 is equal to 1 over square root of 2 times 2, which equals 1 over square root of 4, which equals 1/2. So 1/2 is our correct answer, answer choice B. Next, 11. If f of x equals 3x to the 5th minus 5x to the 4th, what are the x-coordinates of the points of inflection? So again, we need to find a second derivative, but in order to get that, we find the first derivative first. So we have 5 times 3, which is 15, x squared, minus, we have 4 times 5, which is 20x to the 3rd power. And I got this one thing wrong up there. Squared is to the 4th. 15x to the 4th. There we go. Okay, next, f double prime of x is equal to 60 x cubed minus 3 times 20, that's going to be 60 x squared. And so to factor this out, f double prime of x is equal to, our greatest common factor would be 60 x squared times x minus 1. And so our PPOIs, again, we call these PPOIs not critical numbers because these are possible points of inflection. We have x equals 0 and x equals 1. And next we resort to our number line, and we use put our possible points of inflection here: 0, 1, f double prime above, and f below. And if we go to a number less than 0, well, x squared, whether positive or negative, is always going to be positive. So we have a positive times a negative. So what that means is that we are going to be concave down over this interval from negative infinity to 0. And next, a number greater than between 0 and 1, well, if we take 1/2, again, we have positive, and then positive times a negative. So we have that concave down between 0 and 1. And the last thing we're going to do is a number greater than 1. Let's say 2, positive times positive. So we're going to have concave up. So there's only one point of inflection, and that's going to be at x equals 1, because that's where we have a change in concavity, because that's where we have the f double prime of x switches signs at x equals 1. And so C is our correct answer for problem 11. Okay, problem 12. If y equals 2 times cosine of x over 2, then the second derivative, d squared y over dx squared, that's the second derivative. We'll call this y double prime. Or, yeah. So anyway, let's go ahead and work this out. Y prime, which is our first derivative, is going to be equal to, we're going to have 2, and the cosine, the derivative of cosine, okay, we can work this out. If we go down from cosine to sine, we have negative sine, so we have cosine, we're going to have negative sine, and we're going to have x over 2 times the derivative of this inside x over 2, which is going to be 1/2. And so 1/2 of 2 cancel each other, so we're going to have negative sine of x over 2. And now the second derivative, y double prime, is going to be the derivative of negative sine is negative cosine. So I have negative cosine, and we're going to have x over 2 times 1/2. Well, that's going to be negative 1/2 cosine of x over 2, which is our answer E. Next, 13. If the limit as x approaches 3 of f of x equals 7, which of the following must be true? Well, to do this, one thing that helps me sometimes is to draw a little graph to look at examples. So we have this graph right here, and we're evaluating where x approaches 3. So 1, 2, 3, and we're trying to evaluate, we're saying the limit as x approaches 3 of f of x is 7. So up here at 7, we have a value. I'm not going to put down if it's a whole or not, but we have a function from the left side, let me put this in purple, is approaching the value, same value from the right side. Okay? So, what I've drawn is a counterexample here that to have a limit equal to 7, the function does not have to be continuous there through that value of x equals 3. And if a function is not continuous, the function is by definition not differentiable. And then lastly, option 3, f of 3 equals 7. Well, here 7 is, it could either not exist, or the thing could be down here at a value of 5 that would still make this thing discontinuous. And so f of 3 does not necessarily equal 7 either to have that limit exist. And so none is our proper choice for number 13. Or 14, given f of x equals 2x squared plus 1, the instantaneous rate of change at x equals 3 is how much greater than the average rate of change between x equals negative 1 and x equals 2? Well, we'll find the instantaneous rate of change. We're going to find f prime of x, and that's going to be 2x squared. Well, that's going to be 4x, right? And so f prime of 3, because we'll find the instantaneous range at where x equals 3, we have 4 times 3, which equals 12. So that's our instantaneous rate of change, and then we're going to subtract the average rate of change. Well, the average rate of change equals f of b minus f of a over b minus a. And so in this instance, we have, well, let's say f of between 0 and 2, right? F of 2, that's going to be f of b, right? Equals 2 times 2 squared plus 1, which is going to be 2 times 2 squared, 2 times 4 plus 1 is 9. So that's 9. And f of a is going to be negative 1. So 2 times negative 1 squared plus 1, that's going to be 2 times negative 1 squared is, that's going to be 3, right? So A rock, average rate of change is going to be f of b minus f of a. Well, it's going to be 9 minus 3 over b minus a, which is 2 minus negative 1, which is going to be 6 over 3, which equals 2. Well, how much greater is this 12 than 2? We subtract out 2, we get 10. So we have 10 greater, so D is our correct answer for problem 14. 15, the graph to the right shows the graph of f prime of x. Which of the following are true about f of x? Well, we're going to examine here 1. Critical points of f of x occur at x equals negative 3. And we see that this graph of f prime of x does actually touch the x-axis at x equals negative 3. So negative 3 is a critical number. But x equals 2 is not, because we don't have f prime touching the x-axis at x equals 2, so that is not correct. Therefore, condition 1 is not correct. Condition 2, a relative minimum occurs at x equals 1. Well, we look at 1, and here we have f at 1 we have, and we can do a number line underneath. At 1, f prime of x is changing from negative to positive. Okay, so that's going to be the function going down before 1 and increasing after 1. So that is a relative minimum at x equals 1, check. Next, x equals negative 3 is an inflection point. Well, here we have at negative 3, that's negative 2, negative 3, so negative 3. So at negative 3, we have a change of concavity, because f prime of x changes from positive to negative at x equals negative 3. And that is a definition of an inflection point, so that checks out as well. So 2 and 3 are the correct answers for 15. 16, the cost of producing x number of bicycles is given by C of x equals x cubed plus 48 over x. Well, for the interval 1, closed interval 1 to 10, what is the minimum cost? So let's go ahead and take the derivative and see if we can find a minimum here, and then our minimum cost would be the relative minimum between x equals 1 and 10. So I'm going to rewrite c of x as x cubed plus 48x to the negative 1 power. And so c prime of x is equal to 3x squared, and we're going to say minus, because negative 1 times 48 is going to be negative 48, and x to the power of, well, negative 1 minus 1 is negative 2. So that's going to be equal to 3x squared minus 48 over x squared. And so we can set this equal to 0. The first derivative equal to, so we'll say 0 equals 3x squared minus 48 over x squared. And adding 48 over x squared to both sides of the equation, we get 48 over x squared is equal to 3x squared. And if we cross multiply the x squared, we're going to have 48 is equal to 3, and x squared times x squared is x to the 4th power. And then if we divide by both sides by 3, we have x to the 4th power is equal to 16. And if we take the square root of both sides, we're going to have x squared is equal to 4. And if we take the square root again, the square root of x squared is x. X is going to be equal to plus or minus 2. And again, we're really only interested in the plus side because we're interested between 1 and 10. So 2 would be our relative minimum in this interval. And we can quickly test it out if we want to. If we go to 2 and we take a number, say we take a number 1 or something like that, if we plug in 1, we should get a, we put f prime here, or c prime, right, and c down below. If we plug in 1, we're going to have 3 times 1 squared minus 48 over 1. Well, that's going to be negative, right? So we're decreasing. If we pick a number bigger than 2, let's say, what would be a number that would be bigger than 2 that would work well? 6, right? Well, 6 squared, that's 36. 3 times 36 would be 108 minus 48 over 6 squared. That's going to be, it's going to definitely be positive. So we have our relative minimum at x equals 2, and so all we need to do is plug in. So we put in c of 2 is equal to 2 cubed plus 48 over 2, which is going to be 8 plus 48 over 2 is 24, which equals 32. So our correct answer is A. Next problem, 17. The graph of y equals fx in closed interval from negative 3 to 7 has the following endpoints, negative 3, 4, and 7, 1. F of x is continuous on the closed interval and differentiable on the open interval from negative 3 to 7. There exists an x value c such that from negative c between negative 3 and 7 such that, well, this is going to be just another A-rock problem, right? Average rate of change. And that's the mean value theorem, right? Mean value theorem has to exist at c, and we're going to take f of b minus f of a. Well, here we have b is this 7, 1, and a is this negative 3, 4. Well, f of b is going to be 1 minus, and f of a is 4, over b minus a. Well, it's going to be 7 minus negative 3. And 1 minus 3 is, 1 minus 4 is negative 3, and 7 minus negative 3 is 10. So we have negative 3 over 10. So our correct answer is is b. And if we had the function itself, we could see what value c made this apply. We would set the first derivative equal to -3/10 and solve for x. Okay, next, which problem 18, I thought this was the hardest problem of the bunch. You have the diagonal z of the rectangle to the right is increasing at the rate of 1 centimeter per second, and dy dt equals 3 dx dt. At what rate is the length of x increasing when x equals 3 centimeters and y equals 4 centimeters? Well, we're going to do the Fwiggy thing. Find. We're trying to find at what length x is increasing. So we're going to say, we'll call this dx dt, and that's going to be our question mark, right? So we're going to find dx dt, and given, what are we given? Well, we're given that dz dt, the amount the diagonal is increasing, is 1 centimeter per second. We're given that, well, we'll call this the only given right now. We'll say when, it's going to be when x equals 3 centimeters, y equals 4 centimeters, and then our equation is going to be the Pythagorean theorem. X squared plus y squared equals z squared. And as far as z goes, if we have x equal to 3 and y equal to 4, z is going to have to be equal to what at the same time? 5. So 3, 4, 5 right triangle is what we have here. Now we're going to take the derivative implicitly of this x squared plus y squared equals z squared. So that's going to be 2x dx dt plus 2y dy dt equals 2z, that's a z there, dz dt. And what are we given? Well, we're given a lot, aren't we? Let's put everything we're given. Well, 2x is going to be 2 times, well, x is already 3, right? And dx dt, and plus 2 times y is 4, right? Yeah, 4. That'd be dy dt equals 2 times 5, and we have dz dt, don't we? Z dt is 1 centimeter per second, so 1. And so we have 6 dx dt plus 8. Now, we have this condition here. Another thing we were given, I didn't write this down, is dy dt equals 3 dx dt. So we can replace this dy dt with 3 dx dt. And that's equal to 10 on the right side. And so what we have here is 6 dx dt plus 24, 8 times 3 is 24, dx dt is equal to 10. And so 6 plus 24, so we have 30 dx dt is equal to 10. And dividing by 30, we simplify to 1/3. So dx dt is 1/3 centimeter per second, which is our answer choice C. Our last problem here is 19. The function f is defined on the interval from -5 to 5, and the graph is shown on the right. Which of the following statements is true? Well, the first one is the limit as x approaches 1 of f of x equals -1. And so we just examine from the left side, we're approaching -2, our y value limit is -2. If the right side is -2, now the point is defined as -1, but the limit is not -1, so that is not correct. Condition 1 is not correct. Now condition 2, the limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals 2. Well, this is the definition of a derivative, and so we look where x equals 2, and the definition of derivative is the slope. Well, this slope at x equals 2 is going to be rise over run, so we can take up 2 over 1, so the slope is 2. And so therefore condition 2 is right. Now the last thing we have is the limit as x approaches -1 from the right. Well, here's -1, and from the right, okay, what are we approaching? Well, the value of -1. So that's going to be -1, and we look at f of -3, so we go to -3, and we go up to -3. We also get, oops, I said -1. The limit we approach from the left as we go toward -1 is 1. So we have 1 equals, and f of -3 is 1. So they both equal each other, check. So conditions 2 and 3 are valid. So I hope this has been helpful to you. Good luck, and thanks for viewing.